Okay. Um, so cluster analysis is one of the method um, considered as machine learning algorithm, which is used for unsupervised tasks. Unsupervised tasks meaning that we do not have any guidance, but we group the data based on the characteristic of the data. Okay? So for this one, for this session, you will learn the way clustering tasks, which is different from the classification tasks. So you also will learn how the clustering define a group based on the characteristic of the data that we have, and also you will learn how to group the data that you have by using the k-means, and also all the steps required to perform the clustering. So we will look into step by step on how you perform the clustering, in which you group the data based on the characteristic of the data. Okay. So in order to understand clustering, we have to look at the definition of clustering. So clustering is considered as an unsupervised machine learning task that will automatically divide your data into clusters or groups. They are groups or clustered based on the um, distance between themselves. So those are almost similar to each other. They will be grouped into one cluster, and those who are different will be clustered far away from each other in different cluster. Okay. So clustering is guided by the principle that records inside the cluster should be very similar to each other. Okay. So if they are very similar, that means they are very compact. Okay. But if they are not similar, your cluster will be a bit loose. Okay, and those who are having different values or different characteristics, they will be clustered in different cluster group. Okay, so this machine learning method is used for segmenting customers, detecting anomalies, and also simplifying extreme large data sets. For example, in the first one, segmenting customers into groups with similar demographic or buying pattern. So they will look at your demographic, and they also look at your buying pattern. They will group you based on your demographic characteristic or the buying patterns. Okay, so by doing that, they can focus on individual cluster or individual group for the item that they want to promote. In detecting anomalous behavior, we can detect abnormal behavior or anomalous behavior by looking at the outlier. Okay, so when you perform clustering, you will be able to cluster individual item into their own cluster. But sometimes you will find individual item which fall in different area, which there is no cluster at all. So that is what we call outlier. So this is also considered as abnormal behavior or anomalous behavior. Okay. And the third one is simplifying extreme large data sets. Normally, we do it with documents. So we group them based on topics or based on the content of the document. Right? Clustering will tell you which group of example are closely related to each other. So suppose you are organizing a conference, and you want to look at all the participant, you can group them based on their background, based on their research area, so that it is easier for you to look into who are the people attending your conference. Okay? For example, like this, when we talk about what is analysis, we are talking about we try to analyze the data based on the compactness of the cluster and also how far they are separated from each other. Okay, so the more compact they are, the more similar they are in one cluster. The further they are separated, the more difference that we can find from individual item that we have in different clusters. So basically, we are looking at the compactness of the cluster, how close they are to each other. Okay, so we wanted to study how do we minimize the intra-cluster distance. Okay, intra-cluster distance, and at the same time also we are looking at the inter-cluster distance. How do we ensure that all the cluster that we have will be separated far away from each other? Okay, by having that, if we have a very compact and they are separated far away, we can say that we have a good cluster result. For instance, we may have these two. Okay, so the cluster on your left-hand side will be a good cluster because they are very compact and they are separated far away from each other. If you compare to the cluster that you have on your right-hand side, they are very loose, and also the distance are not so far away from the other cluster. Okay, so we can say that this is a good one, a good cluster result. This one is not. Okay, okay. How many cluster we have here? Can you type in your name? How many cluster we have? Two. The other? How many cluster we have here? Two, two, not six, not four, not five. Okay. So the answer is we don't know how many cluster we have here. We could have two cluster, six cluster, or four cluster. So which one is the best one? Okay. So the only way we can find which number cluster that is the best one is we compute how compact they are and then how far they are separated from each other. So for this one, we have two cluster. We want to know the compactness of this cluster and how far they are separated. And then this one also we have six. Okay. So for this one, we have to compute the compactness and also the average distance between the cluster. Similar to this is 4. Okay, so we can never tell which number cluster is the best one unless if we compute the compactness or the compactness and also the separation between cluster. So we will look into that one later on. How do we compute quality of the cluster that we have. Sometimes they call it cluster validity. So clustering is a set of cluster. So we could have two types. We have hierarchical and also partitional. Okay, partitional clustering, we have non-overlapping cluster. Uh, Hierarchical clustering, we have overlapping cluster. So this is your original point. So this is what we call partitional clustering because there is no overlapping. So individual item belong to a single cluster. Okay. Hierarchical clustering, if we look from the top, we consider this one as overlapping cluster. So when we are looking at this P2 and P3 only, so basically we are looking at that. We could also have this one, this tree, this tree. So basically we are looking at here. So that means we are looking at this cluster. Okay. So this is called hierarchical clustering, and this is called partitional clustering. Okay. So let's take a look at the first one first. K means clustering. Partitional. This is also considered as partitional clustering. So what happened is that we will select K point as the initial centroid. Okay. So this K refer to the number of clusters. So if our number of cluster is 2, so K is equal to 2. Okay. If our number of cluster is 4, then our K is 4. So what happened is that we decide how many cluster we want to have, and then based on those value, we select randomly among all the items that you have in your data. You select 4 points as the initial centroid, and then you will repeat for K cluster by assigning all the point to the closest centroid. So meaning that you will look at the other item and then you will assign that item to the nearest centroid. Okay, because the nearest centroid or the K point will be your initial centroid here. So you will recompute the centroid of each cluster and you will do it over and over until no changes. Okay. Okay, for example, like this. Suppose we have this original point. Okay, the the optimal clustering is this, where we have 3 cluster. Okay, this is non-optimal because we have this cluster. So we could have 2 different type of cluster result here. It depends on where you pick your initial point of the cluster or the initial centroid of your cluster. Okay? So for example, like this. Let's suppose we have k equal to 3. So we pick randomly here. 1, 2, 3. Okay, so for the remaining item, we will assign them to the nearest centroid, which is this one. Okay, so this particular guy may be nearer to here. So that's why they are assigned to the green one. Okay, so what happened here is that we select randomly 3 centroid and then we will assign the remaining item to be belong to the same cluster as the nearest centroid that they have. Okay? And then after we compute that, then we find the new centroid again. Okay, how do we find the new centroid? We know that this is our cluster based on the first centroid. So we are saying that, okay, maybe the new centroid is here. And then for this one again, maybe the new centroid is here. And then this one again here. Okay. So, and again, you will repeat the whole thing. You will assign all the remaining item to the nearest centroid. Okay. So if I simulate this from the beginning, it will look like this. Okay. You look at the point of the centroid will be moving to its natural position. Okay. So from iteration 1, 2, 3, and so on. Okay. So in the first iteration only, I pick 3 centroid. Okay. Then I will assign the remaining item to the nearest centroid. Okay. Then after that, I will compute the new centroid. The new centroid will be this, and I will keep updating until there is no changes of centroid. Okay, so that's how it um, perform the clustering task. So at the end, we will have 3 cluster. Okay, so how do we apply in a real world situation? For example, let's suppose we have document. So we have 3 document. So we have 3 document. No, we have 7 document, and we have 2 cluster. Okay, so this cluster is randomly selected. So for this example, I select document 1, document 3 to be the centroid of cluster 1, and document 6 to be my center for cluster 2. So what happened is that I will check whether this belong to this cluster or this cluster. How do I know? I will compute the differences between the term that we have here. So the T1, T2, T3, T4 referring to keyword or term that exists in the document that we have. Okay. So I will compare first. For this one, I'm using the Euclidean distance. So I take the 3 minus 1 square plus 4 minus 2 square plus 5 minus 5 square plus 1 minus 3 square. And then I take the summation and I take the square root. So I will get this one. So this is the distance between document 1 to document 3. Now I want to check again what is the distance between document 1 to document 6. And I found that the distance between document 1 to document 6 is 5.0. The value is smaller for most similar document. So the smaller is the value, the more similar they are. So that means I will take the first one, which means I say document 1 should be belong to the same as document 3. Okay. So now I have cluster 1, 2 members, 2 membership. Cluster 2, I have only 1. Okay. Now I will repeat again for document 2. So document 2, I will check whether this one is nearer to this cluster 1 or cluster 2. So I compute again the differences between this. So 2 minus 1 square plus 1 minus 2 square plus 5 minus 5 square plus 2 minus 3 square, and then I take the summation of all these, take the square root, I get this value. Okay, and then I compare again with this one, so the distance is bigger, so I say that document 2 must be in the same cluster as document 3. So I have cluster 1 here, and cluster 2 still remain the same. So I will repeat again for document 4. Document 4 should be belong to document 6. So I put document 4 the same cluster as document 6. I repeat again for document 5. Document 5 is nearer to document 3. So I put document 5 in the same cluster as document 3, which is cluster 1. I repeat again for document 7. Document 7 belong to document 3. So finally, I have this. Okay. So this is only the first iteration. Okay, first iteration. So when we describe the cluster here, because we have document 1, 2, 3, 5, 7. 1, 2, 3, 5, 7 belong to the same cluster. So the new center will be taking the average of all these term 1 up to term 4. Okay, so I will add up 3 plus 2 plus 1, which is 6, plus 1 again, and then plus 6. So 13 divided by 5, because we have 5 records. Okay? So I take the average also for T2, and then T3, and then T4. So the average will be this, and this is considered as your new centroid. Similar to cluster number 2, I will take the average between these two, document 4 and 6. Okay, so this is your new cluster. So what you will do next will be you will repeat the whole thing again, but now you have new center here. So you want to check whether this is belong to cluster 1 or cluster 2. So you will repeat for all these documents. Okay, any question? Can you type number 7 if you are okay? Boleh paham? Okay. Okay. Now we will look into another method is that how do we measure the compactness of your cluster? So of course when we are looking at this cluster, oh, so if we have this cluster, and then this is your centroid, okay, and we have all the member here. So we can measure the sum of square error, which tell you how compact is your cluster. So we want to know what is the average distance to the centroid of your cluster. So this is basically looking at the distance between all the member in your cluster to the centroid. Okay, so how do we perform that one? Okay. So for example, like this, let's suppose we have these three cluster. So um, how do we compute the sum square error? So first we have to look at what is the center for this, what is the center for this, and what is the center for this. So how do we find that? We just take the average. So the average for this will be 2.5. This is 2.5 again. This is 5. This is 1.5. This is 5. This is 3. So that's how we get this. Okay, so this is the center of your cluster for these three clusters. So now we have to compute the total sum of square for individual cluster that we have using the sum square error. Okay, so let's take a look at the first one. The first one here. So the distance between the center to the first one will be 2.5 minus 3 square and so on. So we get 2.75. Okay. Similar to this one, we are looking at the distance between this to the centroid, and we compute the distance. This is the distance. Okay. So the sum square error for this cluster will be 5.5. We add up this together. So that is the this one. Okay. For this one. So we repeat for cluster 2. So cluster 2 has 52.5. Basically finding the distance between this to the centroid of cluster 2, we get 26.25 and 26.25. And then lastly, we take the sum square error for cluster 3, which we compute the distance between the centroid to the all member of the cluster. Okay, and the value is 56.68. So the total sum square error will be the sum square error for K1, K2, and K3. So we add up all them together. Okay. So the sum square error is this one. So this value, the smaller they are, the better is your cluster, because smaller value indicate you have a very compact cluster. So we can use sum square error in order to tell how good is the quality of your cluster. Okay. Okay. Another issue that we have to look into is that because when we select the K initial centroid, we select them randomly. So every time you run your experiment or your um, practical exercise, they will select randomly K number of initial centroid. So it could be anywhere. Okay, so you may have different cluster compared to your friend who are conducting the same kind of experiment. So for example, like this, um, for this one, it will give me this cluster because the initial cluster was selected one here, and one here. So we will get different cluster results. Okay, so this one tells us that how do we choose the best result for the clustering? Okay, so the best answer is we have to run a few times of um, finding the cluster for the data, and then we keep the best result, keep the cluster that has the lowest sum square error. Okay, because in reality, if you want to try every chances, every probability of having the best one, we have this probability to get the best result. Okay, because we have k factorial number of ways to select one centroid from each cluster divided by number of ways to select k centroid. Okay. Okay. So look at this example. We have selected 10 initial centroid, and when we perform the iteration slowly, they will converge to this. But if we have another example in which we have 3 points here, okay, this is only 2, this is 2, and then this is 1. So when we run out this one, we will have this cluster. So where we have one here, and one here. So it depends on where is your initial centroid. Okay. So like I mentioned just now, the solution is to have multiple run, or you could use the hierarchical clustering. Okay. And you just keep the best cluster result that has the lowest um, some square error. Okay. Any question? No? Can you type number 8 if you are with me? Number 8. Okay. There are some limitation, but before that, let me go. There are some limitation. Um, we will have problem when we have different sizes, different densities, and non-globular shapes. Okay. So we will look into how do we tackle this problem. For example, like this, they have different size of cluster. Huh? So can you see 3 cluster here? Okay. So when you perform the clustering, you will have something like this, which is not a perfect cluster. If you have different density, for example, like this, when you run your clustering, you will get something like this. Okay? So when you try to visualize the cluster that you're supposed to get, and you compare with the one that you get from your clustering technique, it seems that you will have problem here. Right? Okay? This is for the non-globular shape. When you perform the clustering, you will get something like this. So how do we solve the problem? Remember that when we try to form the cluster, we are actually selecting the initial centroid randomly. Okay? So the answer is we have more more initial centroid. Okay? So for this one to cover the different sizes, we use more centroid, similar to the different density and non-globular. Okay, so by having more cluster, you will have um, a better result. Okay, any question?